With legislation around heating and energy changing quicker than ever, it's really hard to keep up with what's true, what's false, and what's actually happening. Fundamentally, there have been two major updates to heating specifications. First is the Part L update of June 2023. So for decades, heating systems have been designed in the exact same way, and that's the Delta T50. What that means is that there's a 50 degrees C differential between the target room temperature and the temperature of the emitters. So typically a radiator would be around 70 degrees C. From June 2023, heating systems need to be designed with a maximum flow temperature of 55 degrees C. And that means that heating systems are no longer designed to Delta T50, they're designed to Delta T30. So on average, your radiator will be around 50 degrees C. As you can see from the radiator conversion table, the correction factor applied to a radiator at Delta T30 is around 0.5. So the output of that radiator is half of what it would typically be. As a result, your radiators need to be oversized by a factor of 2. From 2025, future home standards come into play, which basically means that new builds need to have 70% less carbon emissions than a standard house previously built. This progression in legislation is likely going to cap the flow temperatures at 45 degrees C, meaning that your radiators will be more like 40 or 42 degrees at the surface. This is Delta T20, and Delta T20 commands a correction factor of 0.3, so the radiators will put out about 30% of their ordinary listed values. So let's look at some future home standard examples. So initially, let's look at a 1 kilowatt K2 radiator. You can see at Delta T50, it's about 600 by 600, which is your sort of typical standard radiator size. But when you go from Delta T50 to Delta T20, that radiator is 3 times the size. You've got a 600 by 1.8 meter long radiator. In larger rooms, you could have a heat loss of 1.5 kilowatts or above. If you take a 1 kilowatt K3 radiator, you'll see that it's 1.4 meters long. So if you imagine a 1.5 meter triple panel radiator and think about how deep that will stick out from the wall, that's the size we're talking about. For large, high heat loss properties that might need 2 kilowatts or above, well, they don't even make a K3 radiator that will work at that temperature. Probably because of weight and probably because you couldn't get it up the stairs. Now, most of the people that we come across, they're not exactly in love with their radiators. And so the thought of doubling them or trebling them in size is pretty off-putting. It can even prevent a customer from purchasing a heat pump and improving the energy efficiency of their overall system. An obvious alternative to oversized radiators is underfloor heating. And underfloor heating is a fantastic solution if you want to achieve a nice, evenly spread heat, even at low flow temperatures. However, in many applications, underfloor heating is not practical to retrofit, and if you're installing underfloor heating on a first floor or under thick carpet, it can also create a lot of usability problems. ThermaSkirt for many people solves the 4 key pillars of heating specification. It's future-proofed, so it's ready for the legislation changes that are coming down the line. It can improve efficiency of existing heating systems, meaning that you can lower the flow temperature of your boiler and see a potential gas saving of 15 to 20%. It takes up no wall space, which means that customers don't have to make aesthetic compromises in the pursuit of better performance. And they also haven't got to deal with the upheaval and the deep pockets required to retrofit underfloor heating. Finally, much like underfloor heating, it's got no scheduled maintenance. It's hygienic, easy to clean, and can take a significant level of abuse. But we'll look at that in a bit more detail later.